In the heart of Egypt, where the desert stretches endlessly, there stands a monument unlike any other, a structure built more than 4,000 years ago, still perfect, still imposing, and still mysterious. This is the Great Pyramid of Giza. Its stones have survived sandstorms, heat, and centuries of human curiosity. Yet the question remains, how did people without modern machines create such a colossal structure? And did they possess tools far beyond what we imagine for their time? To answer these questions, we must journey back in time. We must imagine a world without steel, without cranes, without electricity, a world where human skill, creativity, and determination were the only forces shaping reality. The pharaohs of Egypt believed themselves to be gods on earth, rulers who needed eternal tombs to ensure their passage into the afterlife. This belief inspired not just architects, but thousands of laborers, engineers, and artisans to devote years, decades even, to building monuments that could endure eternity. The Great Pyramid is made of over 2 million stone blocks. Some weigh as much as a small car. Some of the largest granite blocks weigh up to 70 tons. Today, we have machines that can lift such weights with ease. Yet the ancient Egyptians moved them using human power, clever engineering, and simple tools. Copper chisels, wooden mallets, stone hammers, and ropes made from natural fibers were their companions. They carved limestone, granite, and other stones with patience and precision. For harder granite, they used pounding stones made of dolerite, a rock so tough it could break granite slowly, stone by stone. Once cut, these massive stones had to be transported from quarries, some located miles away, to the pyramid site. Archaeologists have discovered depictions of workers dragging large blocks on sledges across the sand. Recent studies suggest that pouring water over the sand in front of the sledges reduced friction, allowing fewer people to move heavier stones than one would expect. This method, simple as it sounds, required careful coordination and understanding of physics. The construction itself is one of the most remarkable feats of ancient engineering. The pyramid's sides align almost perfectly with the cardinal points: north, south, east, and west. Achieving this required astronomical observation, careful planning, and meticulous measurement. The Egyptians used the stars, the sun, and simple tools like plumb lines and sighting rods to maintain precision. Every layer of stone was placed with incredible care to ensure stability, and the pyramid's slope was calculated so that it would stand for millennia. It is easy to underestimate the workforce involved. Ancient historians initially believed the pyramids were built by slaves, but modern evidence shows a different story. Teams of skilled workers, often farmers during the off-season, labored in rotating crews. They lived in nearby villages, ate well, and received medical care. Their work was organized in a highly efficient system that ensured continuous progress, despite the enormous scale of the project. The logistics of building a pyramid also extended to stone cutting, transportation, and placement. Each block had a specific location, and the pyramid's internal structure required corridors, chambers, and air shafts to be perfectly aligned. The precision of these internal chambers continues to amaze modern engineers. The king's chamber, made entirely of granite, required blocks to be lifted and set without modern cranes, likely using ramps and levers designed specifically for each stone. Even today, there are debates among historians and engineers about exactly how the ramps were constructed. Some suggest straight ramps that grew higher as the pyramid grew. Others believe zigzagging ramps or circular ramps that wound around the structure. Evidence of mud brick ramps has been found, supporting the idea that the Egyptians used multiple ramp systems in combination. Each ramp would have required careful maintenance, adjustment, and coordination, illustrating the advanced organizational skills of the builders. The alignment and geometry of the Great Pyramid are so accurate that some have speculated the Egyptians had advanced knowledge, possibly lost over time. The base is nearly a perfect square, with a difference of only a few centimeters between each side over 230 meters in length. Some researchers have suggested that this precision is the result of careful observation of the stars, particularly the pole star, and the use of simple but effective leveling tools. Beyond the mathematics and engineering, the pyramid also reflects the Egyptians' understanding of durability. The outer casing, now mostly gone, was made of polished Tura limestone that reflected the sun's light, making the pyramid shine brilliantly in daylight. These casing stones were carefully cut and fitted together without mortar, allowing them to last centuries against the elements. Despite all this knowledge, some mysteries remain. The exact methods used to place the heaviest blocks, particularly in the king's chamber, are still debated. Could there have been tools or techniques that we have not yet discovered? While most evidence points to ingenuity, skill, and labor rather than lost technology, the precision achieved continues to amaze. Some scientists have wondered whether ancient Egyptians understood simple machines, levers, pulleys, and counterweights, far better than we assume. Their approach, combining physics with labor, allowed them to achieve what modern engineers sometimes call impossible. The speed at which these pyramids were built is also astonishing. Estimates suggest the Great Pyramid took about 20 years to complete. For a project of this scale, involving millions of stones and precise internal chambers, this is an extraordinary achievement. Each year, the workforce organized campaigns of stone cutting, hauling, and placement, demonstrating incredible coordination. Moreover, the pyramid was not an isolated effort. It was part of a larger complex including smaller pyramids, temples, causeways, and workers' villages. The planning required to align all these structures harmoniously with the main pyramid indicates a deep understanding of design, urban planning, and logistics. The Egyptians were not just builders, they were master planners, engineers, and architects of society. Some theories suggest that the Egyptians may have had assistance from knowledge now lost to history. Ancient texts and legends describe the use of miraculous tools or hidden knowledge, which has fueled speculation about advanced technology. However, no concrete evidence supports these claims. The tools we do find, copper chisels, stone hammers, wooden levers, combined with human ingenuity, appear sufficient to explain the construction. The most important lesson from the pyramids is not that the Egyptians had secret tools, but that human creativity, organization, and skill can achieve what seems impossible. They worked in harmony with nature, using the sun, stars, sand, and simple machines to create a lasting legacy. Their work teaches us about perseverance, planning, and respect for the forces of the natural world. Every stone tells a story. Every ramp, every tool, every scar on the limestone speaks of the countless hands that labored tirelessly. Thousands of workers dedicated their lives to building a monument that would outlast them, their families, and their civilization. And it did. The Great Pyramid remains standing, a testament to human determination and ingenuity. The question of advanced tools remains. While some mysteries persist, there is no definitive evidence that the Egyptians possessed technology beyond their era. What they had was a deep understanding of simple principles: leverage, geometry, teamwork, and astronomy. Combined with a culture that valued legacy and eternity, these principles were enough to achieve greatness. Even today, engineers study the pyramids to understand how large stones can be moved and placed without modern machinery. Modern replicas and experiments have confirmed that techniques like sledges, ramps, lubrication with water, and clever manpower distribution are sufficient to explain the construction. The combination of observation, experimentation, and careful management was the key. As the sun sets over the Giza Plateau, the pyramid casts a long shadow over the desert, a silent witness to centuries of human curiosity. Travelers, historians, and tourists come from all over the world to marvel at this ancient wonder. They may ask questions, speculate about aliens, or dream about lost technologies. But the answer lies in human skill, patience, and determination. The Great Pyramid is more than just a tomb. It is a symbol of what humanity can achieve when vision, labor, and ingenuity come together. It stands not because of magic, not because of unknown advanced tools, but because humans with simple tools and extraordinary coordination dared to dream bigger than any one person could imagine. And so the pyramids remain. They remind us that the past is not lost, but preserved in stone, waiting for each generation to look closely, to study, to imagine, and to learn. The legacy of the ancient Egyptians lives on in every stone, every alignment, every chamber, and every laborer who left their mark on history. And in their story, we see the truth. It was not advanced tools that built the pyramids, it was advanced human thought.